So on number 1, it's looking for the number of outcomes. This one is not a fraction because it just wants the total possible things that can happen. So I've got 5 equal slots. If I toss a coin, there's 2 sides, and then I'm rolling a 6-sided dice. So there's 3 things that are happening in this problem. And all I have to do is I'm going to do 5 times 2 times 6. I can use a calculator, or I can multiply this by hand. I'm going to do this one in my head, but feel free to use a calculator if that's easier for you. 5 times 2 is 10. 10 times 6 is 60. So there's 60 possible outcomes for what can happen. And remember, outcomes is just another way of saying things that can happen. So I could land on like a red slice of a spinner, get heads, and land on 1 on the dice. On number 2, it's talking about license plates. And when they make license plates, they choose from all the letters of the alphabet. So it tells me there's 3 spaces. So it's going to be something like H-E-Y. I have 3 spots. So each spot can have whichever letter it can. It just needs to be one of the letters in the alphabet. So what I'm going to do for this one is I'm going to do 26 times 26 times 26. I'm going to multiply 26 out 3 times because there's 3 letters. So this one I cannot do in my head. So I'm going to do 26 times 26 times 26, which gives me 17,576. I said 576. Give me 1 second to get it down. Okay, one thing I want to point out is sometimes this problem, it will talk about numbers. So if instead of 3 letters, I talked about numbers, what it means by numbers is something that can go in one of these slots. Remember, I have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I went through and I actually counted those, there are 10 numbers. So if I had this question, but it wanted 3 numbers instead of 3 letters, I would multiply 10 times 10 times 10 times 10. Moving on to number 3, this one talks about probability. And when we start moving into probability instead of outcomes, this is where I start getting my fractions. So this one talks about 2 bags of marbles. The first bag has 9 blue, 2 red, and 4 yellow. So what I'm going to do is I'm going to do 9 plus 2 plus 4 to find out how many marbles are in my first bag. So I have 11 plus 4, which is 15. I'm going to do the same thing for my second bag. I have 6, 8, and 1, which also equals 15. And then it wants me to figure out the probability, or the chance, both words mean the same thing, that both marbles will be blue. So I take a look at each bag. In my first bag, I have 9 blue. So I have 9 out of 15 marbles that are blue. And then in my second bag, I have 6 blue. So I'm going to multiply by 6 over 15. And what I'm going to do is I can multiply straight across, or I can do this in my calculator. I'm going to do this one on my calculator. So I have 9 divided by 15 times 6 divided by 15. Remember, fractions are division on the calculator. I hit enter. It gives me a decimal. This is not what I want. On this test, I'm looking for fractions for probability, so I'm going to go to math. I believe on your calculator, math is a black button, but I could be wrong. I press it. It's the 3rd button down either way. And then my first choice is fraction. So I hit enter twice, and it will turn this into a fraction. So I end up with 6 over 25. Moving on. Number 4 goes ahead and adds the marbles together for me, so I don't have to do the hard math that I did up above. So it just tells me flat out 7 out of 11 are yellow. And then in the second bag, 2 out of 13 are yellow. So on this one, I can multiply straight across or use the calculator. I will use the calculator. I have 7 divided by 11 times 2 divided by 13. Gives me a funky decimal. I go back, I hit math. I hit enter twice, and it gives me 14 over 143. On number 5, this guy is giving out drinks because he's at a board meeting, and you know, sometimes you get thirsty. He has 22 hot chocolates and 23 iced coffees. So first of all, I want to figure out how many total drinks he has. So it's 22 and 23. I add those together and I get 45. Then it wants me to find the probability that the first cup he hands out will be hot chocolate. I should have understood hot chocolate. So hot chocolate was 22. So I have 22 out of 45 drinks he can hand out. Then he's going to hand out a second drink. He's already handed out one. So when I go hand out my second drink, the number in the fraction decreases by 1. And this time, the second drink is iced coffee. He hasn't handed out any iced coffee, so I just have 23 on top. Okay, just like before, once I get my fractions, I just multiply. So I have 22 divided by 45 times 23 divided by 44. Gives me a decimal. I go math, fraction. 23 over, that wasn't on the screen. 23 over 90 is my final answer. Number 6, it's talking about playing a game with friends. Part of the game is rolling 2 8-sided dice and then adding the values together. We want to figure out what value is most likely to occur when I roll 2 dice. So think of when you play games like Monopoly and you're rolling 2 dice, pieces like chance and community chest. Chance and community chest typically have them every 7 squares because 7 is the most likely number to occur when you're playing with the 6-sided dice. And this happens because you just take the number of sides, so 8 on this case, and you just add 1. So for this one, I just take 1 and I add it to whatever I had. So if I had a 4-sided dice, I would add 1 to it to get 5 for the most likely option. Because I can take 1 and add it all the way up. I can do 1 and 8, 2 and 7, 3 and 6, 4 and 5, and then it just starts repeating backwards. Alright, moving on. This one tells me that I have 2 different fractions and I need to decide if A and B are independent or dependent. Dependent means they don't match. They both have D, so don't match. And what I do to figure out if they actually do match is I take the 2 fractions, so I have 12 over 17 times, 8 over 17, and I multiply the 2 fractions. So 12 divided by 17, not 7, 1 comma, times 8 divided by 17 gives me a decimal. I go math fraction. It gives me 96 over 289. So these 2 match, this one and this one. So this one is going to be independent. Same thing for number 8, except this time I'm given decimals. So I'm going to do 0.26 times 0.44 and see if it gives me that decimal over there. 0.26 times 0.44 gives me 0.1144. These don't match, so they are dependent. And what happens, and the reason why multiplying doesn't work and makes them dependent is because on dependent ones, I typically have to add or subtract to find the probability, and multiplying gives me independent. Okay. Same thing for number 9, except this time it gives me percent. So remember with percent, I move the decimal place over 2. So I'm going to multiply 0.70 times 0.22. This one gives me 0.54. 15.4. These do not match because if I move this decimal over 2, it's 0.147. So this one is dependent. On this one, it's giving me a Venn diagram and it wants me to decide what's happening in here. So it tells me A is liking swimming, B is liking hiking. So only this part is shaded, this piece of swimming is not. So what they like to do is they like to swim but not hike. Okay. Moving on to 11, same thing here. A is Batman. B is Superman. And I want to figure out what the shaded region means. So over here on this one, since it's only shaded in between the two, they like both Batman and Superman. Moving on. Another Venn diagram. This time A is rain and B is above 80 degrees. So this one is everything but the middle. So it's an or situation because the middle's not shaded. So it either rains or the temperature is above 80 degrees. Next one is a person, they're in their sock drawer, and apparently they do not put their socks in matching pairs or anything like that. So they just have a loose sock drawer. It's like socks without friends. They have 5 black, 2 red, 6 yellow. So I'm going to take these to figure out how many total socks they have and add them all together. 5 plus 2 plus 6 is 7 plus 6 is 13. So they have 13 total socks. They want me to figure out the probability of going in that sock drawer and pulling out a black sock. So I have 5 out of 13 socks that are black. I'm going to hold on to this sock because I'm hoping the next sock I'm going to grab is black. Apparently I'm getting dressed in the dark and I just don't know what I'm reaching for. So I'm going to hold on to my black sock, which makes the total number of socks in the drawer go down by 1. So now I have 12 socks in the drawer. Next I want to figure out how many of them are red. I have 2. That didn't change because I haven't grabbed one yet. Now I'm grabbing one. Same thing, when I move on to the third sock, I have 11 socks left in the drawer. And I'm still hoping for a pair. I'm hoping for black or red. Unfortunately, I get yellow, so there's still 6 of those in this drawer. So just like before, when I had my fractions, I'm going to take these 3 now and multiply them together. So I have 5 divided by 13 times 2 divided by 12 times 6 divided by 11. Gives me a decimal. I go math, fraction, gives me 5 over 143. Moving on. Number 14, same thing. I have my 3 colors of socks that I'm going to go ahead and add together. So I have 5, 2, and 7. 5 plus 2 is 7. 7 plus 7 is 14. I have 14 total socks. This time she's going to grab a sock and she pulls out a red sock. So she has 2 out of 14 red socks. She goes in a second time. She's hoping for that red sock, but she's pulled out one already, so she's only got 13 socks. Now she pulls out a yellow. There are 7 yellows. So now she's going to go back in. She's hoping for a red or a yellow. And so she has 1 left sock from her last pull. She actually pulls out a yellow this time. So what I'm going to do is, because I pulled out a yellow, that was the 7, I'm going to subtract that one as well. And I have 6. So then I'm going to go ahead and multiply these. I have 2 divided by 14 times 7 divided by 13 times 6 divided by 12. This one gives me 1 over 26. So this one is a little bit better probability of happening because she has so many yellow socks. Okay. Number 15 is a little different. I'm working backwards. It tells me they're independent. Remember, when I'm working with independent, I'm normally multiplying. But because I'm working backwards, the opposite of multiplying is dividing. So it tells me the combined probability is 0.238. So I'm going to do 0.238. And then the probability of A is just 0.34. So I go ahead and divide that by 0.34. 238 divided by 0.34 gives me 0.7. So the probability of B happening is 0.7. Number 16 is also the same. It's working backwards. I need to figure out how many total socks I have first. So I have 7 plus 5 plus 3 plus 1. 7 plus 5 is 12. 12 plus 3 is 15. 15 plus 1 is 16. Okay. It tells me the probability of what has happened. So I had 1 out of 16. And it tells me the probability of my first thing is a red sock. So my red sock probability is 5 out of 16. If I'm working backwards, I want to divide by the fraction or flip the fraction. So I have 16 over 5. What I do for this is I multiply and 1 divided by 16 times 16 divided by 5 gives me 1/5. Notice, when we did the soft problems before, I went from 16 to 15, not 16 to 5. I can turn 5 into 15. I have to multiply this by 3 over 3. To keep the fraction the same, it's the same thing as multiplying by 1. Because 3 divided by 3 is 1. So I get 3 over 15. So now what I'm doing is I'm looking for the sock choice that has 3 possible colors, or 3 of the colors. If I look up here, I have 3 yellow, so my answer here is yellow.